The broadcast is now starting. All attendees are in listen-only mode.
Welcome to Safety Law 18, where we're going to talk about flammable atmospheres. My name is Trish Kerin, and I'm the Director of the IQME Safety Centre. I'd like to start today by acknowledging the traditional custodians of the land where I'm speaking from, the Wurundjeri people of the Kulin Nation in Naarm, and pay my respects to their elders past, present and emerging, and extend those respects to any Aboriginal or Torres Strait Islanders we have listening today. So, we're going to talk about flammable atmospheres and what that actually means. In terms of, first of all, the IQME Safety Centre members, it's really important to acknowledge their membership in the centre. Without you contributing to our work, we would not be able to do what we do, so thank you. And also extend thanks out to our supporting partners around the world, helping to improve education. Now, let's talk about what a flammable atmosphere actually is. So first of all, we need to understand what a flammable substance is. So a flammable substance can include solids, gases, liquefied gases, aerosols, mists, and atmospheres. There are three different elements that are required for ignition to actually occur when you have a flammable substance present. A fourth element is also required to maintain the fire once it's actually started, and that is an uninhibited chemical reaction. So that's typically shown, historically it's been shown as the fire triangle. We now call it the fire tetrahedron. So we need the fuel, which is our flammable substance. We need the oxidant, which is typically air in the atmosphere when we're talking about flammable atmospheres. We need the ignition source to actually cause the initial ignition. That could be hot work, a hot surface, a number of other things. And then we need the chemical chain reaction to sustain that combustion as it continues to burn. Let's talk about the two cases that we have within the safety law this month. So the first case I want to talk about is the case of a chemical company. So on November 9th, 2010, a contract welder and foreman were repairing the agitator support on top of an atmospheric storage tank, tank number 1. The tank service was a flammable substance called vinyl fluoride. While the welding was being performed, flammable vapours inside that tank ignited and caused an explosion. The welder was killed in the initial blast, and the foreman suffered burns and minor injuries. The initial work was done while the slurry tanks were isolated and out of service. However, the actual final welding work was delayed because of material availability. So when the work recommenced, Tank 1 remained out of service, but the isolations to Tank 1 had been removed. There was also a vent line that connected the vapour space for Tanks 1, 2 and 3 that was never isolated. When Tanks 2 and 3 were returned to service, vapour migrated to the Tank 1 vapour space. This connection provided the pathway for the flammable vapour to be present in the tank being worked on. So, in terms of some of the key findings for that particular incident, work on these tanks had commenced when all 3 tanks were out of service, but due to delays and a scope change of repairing the agitator support, Tank 2 and 3 were returned to service, meaning their isolations had been removed. The presence of a common vent valve meant that vapours could travel between those tanks. Tank 1 was not adequately isolated or vapour-free when the welding took place. The late change of scope meant that the work was not planned as part of the initial shutdown activities. The permit to work form was not completed thoroughly, skipping the section discussing potential flammable atmospheres. So you can see there are a number of different things that fell down in that particular incident, most notably that the scope had changed, but the work hadn't been reassessed, and then the isolations hadn't been rechecked to ensure that there was no pathway to have a flammable atmosphere in the tank that was actually being worked on. Let's talk about the second case that we had in the safety law, and this one actually took place at a winery. On January 17th, 2008, a contract welder was working on Tank 104 at a winery. He was working alongside the chief winemaker and the assistant winemaker. The welder had visited the winery a few days prior to the incident to scope the work to install an upgraded cooling system. This work involved welding on a stainless steel tank. When the welding was being undertaken, there was no indication that that tank was in service and that it contained ethanol. Welding ignited the flammable atmosphere, resulting in an explosion which killed the welder and the chief winemaker. The assistant winemaker suffered serious burns as a result. Now, around a week before the welding had been performed on tank 106, a delivery of ethanol arrived. And they ended up putting that ethanol into tank 104 at the time because 106 was being welded on and they needed to put the ethanol somewhere. When the welding was then arranged for tank 104 later the next week, the contents of the tank were not checked and there was no effective safe system of work to identify hazards and document controls that needed to be implemented as part of that welding hot work. No atmospheric testing was conducted prior to the welding, nor was the tank positively isolated. So again, what we're seeing here is a change of scope that hasn't been taken into account from when the job was investigated and determined what would be done to when it was actually being undertaken. The circumstances, the environment had changed. And in this instance as well, there was no permit to work system, there was no effective isolation system, and there was no vapor monitoring or gas monitoring to determine whether there was a flammable atmosphere at all present. So they were the two cases that we talked about. Let's look at the lessons for management out of the safety law. So here it's really important for managers to ensure that their safe systems of work are comprehensive, in place and followed. They need to ensure that people understand the risk of hot work when it's being undertaken. Ensure there are written procedures for the operation of tanks, including adequate labelling. Ensure fire protection equipment is in service and adequate when any hot work is being undertaken. Ensure any changes to scope are assessed and managed. Ensure all personnel involved in the permit to work system are adequately trained and competent. And to ensure that the hazards and controls are identified on any permit issued and that the workers understand those hazards and controls. And lastly, that all isolations are documented, and management should perform a line walk to verify this, because when we're doing hot work, we are talking significant hazard activity. For the engineers and supervisors on the site, you need to make sure that you follow the company procedure in the work that you're actually doing. You should be performing regular checks on the work that's being done as a supervisor to ensure that it's in a compliant manner. Ensure that atmospheric monitoring is being undertaken during any hot work. Ensure all scope changes are fully assessed prior to the work being undertaken. Now, this is an area that we often see creates incidents from a safety perspective. And that's because the scope of the permit to work slightly creeps and people do their very best to continue to just do the job and get the work done without stopping and reassessing. Have the hazards changed because the scope has changed? Have our conditions changed? What additional controls or different controls might we need because of that scope change? Ensure that the safe work systems are implemented and being followed by everybody. Ensuring that all hazards and controls are identified on any permit that's issued and that the workers understand those hazards and controls. And again, making sure that isolations have been documented and performing a line work as a supervisor for any work that's taking place. From the operator's perspective, so these are the people at the front line working alongside the tradespeople that are doing usually hot work activities. The operators need to ensure that the permit to work process is in place and that they're in control of what's going on. So all isolations are in place. All atmospheric monitoring is in place that's necessary. Perform regular checks to make sure that the controls are being implemented. Report any deviations from the permit and ensure that the plant is returned to service safely at the conclusion of the work. And so all these activities do revolve a lot around the idea of your safe system of work or your permit to work process. It is predominantly the most significant control measure you have when it comes to flammable atmospheres, because it's the one control measure that allows you to introduce an ignition source into an atmosphere that could have a flammable substance present in it. So once we've got the flammable substance, if we're in air, all we need is the ignition source to start up that fire or explosion activity. The permit to work system is the only control we have to manage the introduction of that hot work activity into the space. And that is why the permit to work is just so important. The isolations that are required as part of it to make sure that we keep the flammable substances away as much as possible from the work that we're doing, that we monitor that atmosphere so that we know if our conditions or environment actually changes, and to make sure that the work remains within its scope. We understand what the hazards are because we've adequately planned that activity and done the risk assessments to ensure we can do it as safely as possible. One of the key elements that I learned early in my career around permit to work systems and using them is when it comes to doing high hazard work, ask yourself a couple of key questions when you're assessing whether that work needs to be undertaken. Do I need to do it now? Do I need to do it here? And do I need to do it in this way? So do I need to do it now, or is there a better time, a safer time, when I've had a chance to potentially remove any flammable substances from the atmosphere? Do I need to do it here? Can I remove the work to a safe area? In some instances, this is possible, and you may have safe work bays where you can undertake hot work safely within a facility because there are no flammable atmospheres around it all. And do I need to do it this way? Does it actually need to be hot work? Could you, if you need to cut into a line, could you cold cut that line with an air hacksaw rather than using an oxyacetylene torch potentially? Are there different ways that you can achieve the outcome you're looking for? So I always try and remember those questions. Do I need to do it now? Do I need to do it here? Do I need to do it that way? Or can I do it a different way? And that's a way to try and really focus in only doing high hazard or hot work when you have absolutely no alternative. We shouldn't just be routinely doing it. It should be a specific thing that we try and avoid wherever we can. And I think for me, that is one of the most significant learnings of managing permit to work and in particular hot work systems in my career. I just want to leave you with this quote. And this is a quote from Dame Judith Hackett, who said, "There are no new accidents, just different people making the same mistakes because of a failure to recognise the relevance to them of other people's experience and therefore not learning." The two cases that we went over in this webinar and in the safety law were two of hundreds, possibly thousands of hot work related cases I could have chosen and obtained a fair amount of detail on. Sadly, hot work issues involving flammable atmospheres are very, very common in all sorts of processing facilities. And sometimes it doesn't even need to be a flammable atmosphere specifically. Another area that is often a result of hot work activities are things like cooling towers. Hot work in cooling towers can actually lead to fires in cooling towers, which is something we don't often think about because it's counterintuitive. They're full of water, but they can actually catch fire, and that can be a problem. So can roofing material. And so welding near roofing material can have an issue as well, because you can end up with burning down facilities through hot work activities because we have flammable substances in the area. Not necessarily a flammable atmosphere, but flammable substances that can actually ignite, and therefore you can end up with a fire occurring at that point in time. Now, I'm certainly happy to take any questions that anybody may have on this topic. And if you'd like to go to the questions panel, you can actually type your questions in there and I'll go through and answer them. Thank you very much, everybody. And I'll just leave my contact details on the screen for you and see if we've got any questions from you all. We're also starting to plan our next few webinars at the moment. So if you have any specific topics that you might like to have covered in future webinars, please reach out to us and suggest those topics, and we'll see if we can either deliver that webinar or contact and engage someone that can deliver that webinar for you. So we're delivering the content that you're interested in seeing. Okay, it appears as though we do not have any questions at this point in time. Thank you all very much for your attendance today. A nice, short, sharp webinar on flammable atmospheres. The next safety law will be released around September, and in that issue we're going to be talking about confined spaces. Again, if you've got any topics that you'd like to suggest for our safety law, please reach out and let us know so that we can make sure we're addressing the topics that are of most interest to you. Thank you very much, everybody, and please stay safe.